So for today, our topic is weight loss. It's not about diet and exercise. Right here, a lot of times I hear clients saying, I'm eating all the right foods, I'm exercising. My doctor, he's saying how I lose weight is I'm not exercising enough. I'm eating too much, things like that. But it's not surprising that so many people hear that and they do exactly that, but then they never get those results. So obviously something's missing to that part of the story. And absolutely, there is a huge piece is missing to that part of the story. So today you won't hear me talking about the usual stuff, saying don't eat that whole bag of chips and, that 6-pack of beer and, all the usual stuff. This is going to be quite different. So like I said, ask questions. I want you to be asking questions of me, fact checking me, your doctors, any healthcare professional. My purpose here today is to be giving information and educating. I'm not telling you what to do. All I'm doing is providing you with information that then you can fact check me and use it however you see fit. I'll give you suggestions that I use with my clients that work extremely well and is very different than kind of the mainstream of what you know. Like I said before, diet and exercise not being the most effective strategies for losing weight. We see this with people saying following the whole calories in, calories out kind of thing, and they're counting all these things and they still keep gaining weight. We're going to answer that question today. Second bullet point here, calories in, calories out doesn't work, and why calorie counting is pointless and why using calories as a measure for our food intake is probably not the wisest thing to do. On top of that, we're going to be looking at why and how your body actually decides to store body fat. A lot of people don't realize how the process actually works. I'm going to try to make it as simple and easy as possible. Sometimes some of the stuff I talk about can get a little bit scientific, but I try my best to kind of give you a statement, give you the simple 1 + 1 = 2 kind of answer. And then I'll give you the evidence after that. That's when sometimes it gets a little bit scientific, just because that's where the answer is. It's in kind of biochemistry and quantum physics based. But I'll make it, biochemistry and quantum physics for dummies kind of thing. So you understand how your body actually works. And when you know how that works, you can ask really good questions of me, of your doctor, and get to the bottom of, why am I actually putting on weight and kind of what is the answer to that? And why exactly supplements and medications and meal replacement things really aren't the answer to actually managing weight. Using those things is completely ignoring how the process works in general. So when you understand that process, you know better than to be using some kind of supplement in order to kind of fake it to make it, if you will. If your blood sugar is an issue and you just take a medication to lower blood sugar, but completely ignore the reason for why the blood sugar is high in the first place, you're never going to get to the root cause of the answer. And a lot of times what you end up hearing as why your blood sugar is high or why you're obese or overweight is, again, it's you're eating too much sugar, too many carbohydrates, you're eating too much food. But like I mentioned before, there's plenty of people that cut carbohydrates and sugar and all that out of their diet, yet their blood sugar is still high, A1C levels still high. And, doctors are kind of discrediting you, don't believe that you're actually trying. They say, here, take this medication. And to me, that's just not cool. That's not medicine. That's not how this stuff works. That's not how you create lasting, permanent, positive change that addresses root causes. So that's what we're doing here today. And of course, at the end, like I said, I'm going to give you my suggestions for what I do with my clients, my friends and family, and what I suggest to them, and what works extremely well. And this is all the stuff I'm going to talk about is all stuff that is mostly free to extremely cheap. I'm not trying to create customers like a lot of our modern and allopathic medicine likes to do. By offering all these, magic gadgets and foods and solutions, top 5 fat burning foods, all that is just gimmicks and tricks. This is when you understand how the process works, it's really easy to reverse these conditions because you just do the opposite of whatever has caused that issue in the first place. Just this morning when I went into my office, there was a newspaper on my desk, or not a newspaper, but it was a health paper that had an article about why it is that we're becoming sicker as a world population. And the point of the article is essentially what she was getting at was we're not eating our fruits and veggies. We've all heard that so many times at this point, but today you're going to learn exactly why fruits and veggies aren't always health foods. My little brother right now is in Antarctica working on a contract job. For him, that means fruits and vegetables are always going to be damaging to his biology. and will cause things like diabetes, obesity, weight gain, all that kind of stuff. And at the end of this presentation today, you'll be able to answer exactly why that is and why he should not be eating his fruits and veggies. So let's move along here. So like I said, our popular weight loss belief is that it's eat less, exercise more, basically. Calories in, calories out is the mantra that everyone uses. Bunch of, people do math, try to, say I'm burning this many calories and I'm eating this many, so that means I should be burning this amount of fat. The reality is that's not the truth of how any of that works. And we'll get to that in a little bit, but the idea is a lot of people just know that doesn't work because they say, I'm an example of that. I exercise like crazy. I barely eat anything. I eat like a bird. And still I gain 30 pounds after, just breaking my back for this. An example of that being something like The Biggest Loser, the show, is, they go through intense physical exercise and they go through, eating very structured, restricted diet. And people have these, transformations where they lose a bunch of weight, sure. But then if you follow up after the show, what they do is they get back to the regular weight and then gain some on top of that. Essentially what they've done is stress out their biology and then ruin their metabolism even further by using calories in, calories out methodology. So it'd actually be very dangerous to use and doesn't really, get you anywhere. And that's, in my experience with my clients, that's usually how people walk in. They say, I'm overweight, trying to lose weight, and I'm following this calories in, calories out, and all that keeps happening is I keep gaining weight. And I completely understand the frustration and the confusion because you ask a nutritionist or a doctor, and then they kind of just keep repeating the same spiel about calories in, calories out, and macronutrients, when that is not how the body accounts for energy, uses energy, accounts for when to store body fat or, any of that stuff. So just knowing those things, you end up at a point where there's, the diet and exercise isn't working. And then you end up at a point where you start using medications and things because it's like, well, nothing else is working. I guess what my doctor's saying, this medication must be the case. And I'm telling you that's not. And I spend a lot of my time getting a lot of my clients off of supplements and medications, things like that, because they're not needed when you understand how the things work. In fact, for calories, it's not a good measure at all of energy. Our body actually has built-in mechanisms to deal with excess calorie intake. And so really when everything's working properly, metabolism completely handles everything you need to do. And you will never store body fat. So this slide looks very complicated. I'm going to walk you through it step by step so you understand exactly how our body handles when we eat food. The idea here is, like I said, mechanisms in place within us, within our biology, are when we eat food, it is essentially we're eating energy. Our body has the choice then what to do with that energy. When you kind of know exactly the defining things behind this, it's easier to understand it. So the idea is, what is a calorie? A lot of people, you ask them that, and they're like, it's the thing in food that is there that I want to eat little of, and don't really know much more than that. A calorie is just the energy, the heat energy that it takes to heat up 1 kilogram of water by 1 degree Celsius, is what it is. So essentially it's heat. So when you look at the nutrition facts on the back of a food label, what you see is caloric content, which basically says, well, how much heat is that food going to produce, is actually what it's saying. If you look here on the slide, I have a little picture of cellular respiration. It's kind of tiny, but what you see at the very end of it, it says energy, ATP, and heat. So that's our metabolism, is this cellular respiration. It's the reverse equation of photosynthesis. So in photosynthesis, plants use sunlight, water, and CO2 basically to make life our food web happen. That's what creates the plant. That's what makes the oranges that the orange tree grows. That's what grows the corn, all that good stuff. And that is basically coming from those constituents, and that ends up creating from that oxygen that we breathe in, and it creates sugar that makes up the foods that we eat. So cellular respiration being the opposite then is the sugar that we eat. It ends up being the oxygen we breathe in, and then what comes out on the other side of that equation then ends up being carbon dioxide, which is what we breathe out. So it's just kind of a product that we get rid of as a result of this. and then it makes water within our cells, as well as energy and releases heat. So that's where the reverse photosynthesis part comes from, and that's what the metabolism is how much heat is created from these foods. On the second picture here, it shows exactly kind of how that ends up happening. When you eat food, it is a package of energy that moves through all these different processes and proteins within our body. If you look under the little blob that says UCP, it says heat. UCP stands for uncoupling protein. So these proteins within our cells, what they do is essentially create heat based on the foods that we eat. So when we're eating food, what it kind of looks like is a package of what kind of the popular belief is a package of calories, of carbohydrate, of protein, and of fat. The problem with that kind of being is that that's not how the body accounts for energy or nutrition or anything like that. If you look in the body, there's no receptors for calories or carbohydrates or fat or protein or anything along those lines. So it doesn't really make a whole lot of sense to account for things that way. How the body actually accounts for nutrition and energy is through subatomic particles. And that sounds really fancy. Those things mean electrons, protons, and photons. Like I said earlier, when plants make the food that we eat, it captures sunlight energy, combines it with liquid water and gas, CO2, to actually make physical food that we eat. So really, it's actually just a combination of electricity and light is what's in food. When you eat something like a potato chip, as it goes through digestion, it breaks the bonds apart to then be able to access that electricity and light basically within that food. When you look at the second picture here with all the H's and the numbers and the fanciness that is really nerdy, what you see is that what it does is it takes the electricity and actually moves it through a cell. And when it does that, that's the energy. And then the cell has the decision whether to make energy from it. It has the option to make heat from it, and it also has the option to store it as body fat. So if metabolism is working 100% like it should, what ends up happening is all the energy from the food will move through your cell, and it will make as much energy as your body demands. Anything extra ends up being released as heat. Like we said earlier, any excess calories that you eat way too much food as energy, your body will actually just heat up and burn it off. This is actually the same mechanism that creates our body heat. That's why we should be staying warm. And, just as a world population, knowing we're all getting sicker, all gaining weight, things like that, kind of when we see that, and we also know that a few years ago, they lowered like the standard body temperature by a whole degree. So what that tells me is that people's metabolism is getting much worse. It's not being able to create the heat that they need to. So that being said, it's also shows the point that not everyone actually handles calories the same. If a calorie is the amount of heat you make from food, but then people aren't actually burning as much, creating as much heat from eating that food, what ends up happening is if it's not making energy and it's not making heat, it's getting stored as body fat. This is why a calorie is not necessarily always a calorie. A calorie is just talking about the heat that's being created from metabolism. So if you eat a bag of potato chips that's 100 calories, it should be creating 100 calories of heat, but it's not if it doesn't have metabolism working at 100%. Instead, as energy moves through your cell, what ends up, it doesn't create energy for you to use, it doesn't create heat to actually keep you at the right body temperature and do a bunch of other useful things. It ends up getting shuttled toward body fat. And we'll get a little bit more into that a little bit later, about how that actually works and how to kind of turn that around. What I had mentioned earlier about my little brother being in Antarctica and fruits and veggies not being a health food, it points out that there's no one diet for everybody, where we have tens of thousands of diet books, but no one seems to be able to find that one winning diet that works for everybody. And that's because context is super important when it comes to health, medicine, food, weight gain, weight loss, whatever it is context is always kind of the number one thing. These uncoupling proteins are actually somewhat of a mutation within cells. So you can have kind of two different types of metabolism. There's one kind that's called coupled metabolism. And this is kind of the original metabolism that was when we were way back when we were cavemen, we were along the equator. And that's where coupled metabolism comes into place. It's very efficient. it creates very little heat and it creates a whole lot of energy for us to use. And in those conditions, people don't handle calories and food as well. And so with that kind of metabolism, you actually end up eating a lot less food. And the other kind being, as we actually migrated to higher latitudes away from equatorial zones, our ancestors moving up north naturally kind of got into different living conditions, which actually caused mutations within genes that then coded for different types of metabolism. So they actually survive in these different conditions. Living on the equator is very different than surviving further up north where it starts actually having winter and snowing, which is a big part of why there's no one diet for everybody, and it's always going to be changing year round. Me being in Raleigh, North Carolina in the United States, that means I have 4 distinct seasons throughout the year, which means I should have 4 different ways of eating and transitioning throughout the year to actually keep up with the changes in my metabolism. So as people actually move away from the equator and actually have more of those uncoupling proteins, what they have an inefficient metabolism, which ends up meaning they create a lot less energy from food, but they create a lot more heat from it. And that mutation happened, obviously, as you move away from the equator and you get a lot colder, you need a way to create a lot of heat. So as an effort to do that, what happened is the gene that programmed the proteins within our cells, programmed that metabolism, it actually started creating more uncoupling proteins and making a weaker metabolism, and actually an effort to create heat at the expense of losing energy, which works really well when you move up north, which is why as you get further from the equator, you actually need to eat more food if you live in a colder environment to actually be able to create heat, and you don't create as much energy, which we'll get to a little bit later, and kind of how to get through that, and also get to why all this is also really important, what you can do about it to kind of leverage your own weight loss efforts. But to round out everything is understanding that there's so many ways that a calorie is not a calorie. Metabolisms are completely different, and it's when metabolism is working right, we handle excess calories easily, not a problem. Kind of one last point, just to kind of knock calories completely off of your radar. They shouldn't matter at all. I encourage my clients not to count them. They don't matter unless your metabolism isn't working well. Even then, they're not that important because, like I said before, if you eat less calories or more calories, you can still gain weight. It doesn't matter. So I encourage people not to count calories. It's not a useful measure of anything. The one last piece that I'll give you is that we have different kinds of metabolism. If you look at all the different ways we metabolize food, it's a huge map that will boggle your mind and fry all your brain cells because it's so large and complicated. So the 2 different ones, I'm going to give an example here, are carb and fat. So showing that the calories are just heat, essentially, is when carbohydrate goes through carbohydrate metabolism. Kind of the byproducts and the end products of that are kind of what we described earlier, where you get heat, water, and ATP as energy. ATP is basically just an energy storage molecule that our body uses to create energy. So the idea is, I'll give you an example of a potato chip. A potato is a carbohydrate, and the chip itself is going to have some kind of oil on it. In this case, we'll give the example of the new healthy potato chips that have coconut oil on it. So that is going to be a fat. So the potato part of that potato chip then is going to go through carbohydrate metabolism and end up basically as 30 ATP, and 1 gram of carbohydrate is 4 calories. So that is saying there's 4 calories of heat from 1 gram carbohydrate, and the amount of energy is 30. From the coconut oil that's on this potato chip, it ends up moving through a process called beta oxidation, which is how we actually metabolize fats. So right here is our coconut oil. It is what is known as an 18-carbon stearic fatty acid is contained within coconut oil. When we metabolize that, we end up getting 120 ATP or energies, and 1 gram of fat is 9 calories. So when you look at it, it's calories obviously aren't equivalent because we're in the process of metabolizing both. We get twice the heat for metabolizing fat, but 4 times the energy. So if you ate the equivalent calories of both, you end up with 4 times the energy from eating all your calories during the day in fat. That's not necessarily what we want to do. It's just pointing out that calories are not the answer. And I'm just driving that home because that's what everybody wants to talk about. They want to talk about macronutrient splits and calories and exercising, all these different ways to try to, lose weight. But really, that's not where any of the answers lie. Let me take a look, see if we have any questions here so far, and I'll answer them now. It doesn't look like there's any questions, so I'll keep going right along here. And if anything doesn't make sense as I'm going, feel free to put it in that chat box and ask the question. So that way we can kind of cover it as we're talking about it. So everyone has the context of what's going on. And I want everything to make a lot of sense. The last thing to kind of mention about this is if we look at what's going on in the bottom two things, I threw those molecules on there because that's, like I said, how the body actually accounts for energy. It's counts in subatomic particles. It's when you look at these two structures is you start seeing how the body actually looks at carbohydrate and fat. It doesn't see it as carbohydrate, fat, and protein. It sees carbohydrate as these rings with a bunch of oxygen on it, and fat as a bunch of carbon and hydrogen with some oxygen on it. And that's all those things carry electrons and light and photons and all those kind of things. And that's how the body actually stores energy, accounts for energy, uses energy. And if you look at any biochemistry textbook to see how human metabolism works, it's always in terms of those things. Calories really aren't mentioned other than the heat given off from metabolism. All righty. So then the big question is, well, like everyone wants to know, like, how does our body kind of decide then to store fat? So when it goes through that metabolism, I gave the example of 100% efficiency. For when our body eats food, it ends up being kind of turned into heat or energy. Anything extra, when our metabolism becomes broken for any reason, it ends up storing body fat, which we'll get to in a second. I see we have a question though. The question is, in terms of drugs, why are folks losing weight with all these weight loss drugs, Ozempic and such? Yeah, so with Ozempic is essentially replacing insulin, is kind of an easy way to think about it. So kind of the issue and how it's seen is you go into your doctor and Ozempic is prescribed for weight loss and diabetes, so high blood sugar and insulin resistance. You're not able to use insulin effectively. So when you have circulating high blood sugar moving around, and your body then doesn't have efficient metabolism, like I said, and that basically that blood sugar in your bloodstream is then going to be turned into body fat. And I'll get to exactly why here in a second. But just for now, just to answer this question, is that the idea that the doctors are looking to do is reduce that blood sugar as the answer to, first of all, if that blood sugar isn't there, then it's not going to be stored as body fat, as well as it's kind of the way to then also kind of handle the diabetes problem. The issue with that being is it ignores all the other aspects and mechanisms of physiology and how everything works. So if your body is becoming insulin resistant, there's a purpose and a reason for why it's doing that. There's also a reason why that blood sugar is elevated. What you end up seeing is that you end up causing some pretty harsh side effects from using things like that. Like on the surface, yes, people say I started using Ozempic, my blood sugar went down, I had, I lost weight, all these great things. People say I slept better, all those things, but it's not addressing the root cause. And then you also are going to end up with the side effects of supplementing something that your physiology doesn't recognize. Anything you put something foreign into your body that shouldn't be there, it doesn't have the right controls to actually use it long term. Initially, you might have some relief of symptoms, but then kind of the usual train of thought with allopathic medicine is you get your first prescription, it works somewhat, but then you have some side effects. So then you get your second prescription to handle the side effects of the first one, and you end up getting this chain of 17 different medications to handle all the side effects. So that's kind of, you can lose weight, but again, it is a short-term solution that causes kind of more damage internally, to where you get happy because kind of the symptom you want to go away has gone away. But in the long term, you end up at quite the detriment for what's going on. Your metabolism will continue to fail. And you may lose weight and handle blood sugar, but the idea is metabolism is supposed to be there to give us the energy we need to actually run all the body processes. So just by using Ozempic to handle blood sugar doesn't handle your body actually getting the energy it needs. So you'll just kind of end up getting all sorts of other diseases and issues popping up. And then that's, that's, like I said, it ends up with a chain of medications then, because you never handled the original problem. Kind of how medicine should be done is looking at why these things are there in the first place. So I hope that answers the question. If it doesn't, let me know, and what part I can clear up for you. Alrighty. And all right, so how our body actually stores body fat is what we're going to get into now. This is the kind of the most critical piece of the story to understand, and it'll almost be intuitive of kind of what to do about it kind of once you know. Oh, excuse me. So your body has a hormone called leptin. Leptin is really cool. I consider us to have two master hormones, one of them being leptin, the other being melatonin. They have a huge array of different functions. They're called pleiotropic hormones, which means that their function changes depending on the context they find themselves in. And that's why if you look up the functions of either of those hormones, it's just like a short novel of everything it does. It doesn't do them all at the same time. It does them depending on all kinds of different factors, whether you're asleep or awake, and whether you're fed, not fed, things like that. Traditionally, what leptin is known for is just being the hormone that is what tells you that you're full, like you're not hungry. The opposite hormone being ghrelin. Ghrelin is there, and that is what kind of makes you hungry. It stimulates appetite. So our leptin actually comes from our fat cells. So the more body fat that you have, the more leptin you actually release. The less body fat you have, the less leptin you release. Leptin circulates throughout the day and night. It is highest at night and has a peak at night. So what ends up happening is at night, this leptin comes from our fat cells and travels up our vagus nerve into our brain, specifically in the spot in the brain called the hypothalamus. The hypothalamus is kind of the headquarters for all your hormones. It also contains the clock of your entire body. So the clock in your body is called the suprachiasmatic nucleus, the SCN. What you need to know about it is it's the brain clock. Why that's important is that what that tells us about leptin essentially is that it is extremely tied to how our body actually tells time. When you have a hormone that its receptor is in the brain, in the clock, obviously when kind of our clock is off, it's not able to actually get in there, which ends up being the issue. So it's not necessarily leptin, the hormone itself, being the issue. It's actually the receptor within your brain, within your muscles, within your liver, within your pancreas, within a bunch of other organs and neurons throughout your body, actually not accepting leptin. Why that's important is leptin is the body's energy accountant. So kind of the analogy I like to give is that accountant, the idea of it being the accountant. When it travels from your fat cells up into your brain, what ends up happening is it informs your brain how much energy you have. That's why it comes from your fat cells. It says, this is how much energy we have. This is how many electrons we have, is really what it says. And obviously, if it has those receptors that it can't get into your brain has no idea how much energy it has. That's like trying to log into your banking app to see what the balance in your bank account is, and you just can't log in. And when you don't know how much money you have in your bank account, what ends up happening is that you don't want to spend money. So you don't want to spend energy, obviously. You don't know how much you have, so you don't want to waste it. And then second is you want to deposit then. If you keep depositing a ton and not really withdrawing, you know your balance is probably good, even though you can't check your bank account. Leptin is what is the password to let you actually see what's in your bank account. I used to carpool with a guy that his gas gauge in his truck was broken. And so it always freaked me out. I was like, how does he know how much gas he has? He's going to break down somewhere. And so it was always in my mind, I was kind of thinking is like, he has to always be putting gas in like almost every time just to make sure, or trying to gauge it properly. And it's just like leptin. It's like not having any idea how much gas is in the tank, you're going to freak out, which actually kind of creates a cascade of all sorts of other issues. When your body can't account for leptin status or energy status, it does exactly that. It actually does freak out and creates a stress response. So when the body doesn't know how much energy it has, it's got to assume that it should be looking for energy all the time, which is where that part of leptin, where if it's not getting into the receptors, first of all, you're going to feel either hungry all the time or never hungry. So it creates issues with appetite right away, like we covered earlier. But kind of secondarily, just that stress response in itself, what ends up happening is when leptin doesn't get into that receptor, is it creates a stress response, which cortisol is what we all know as that stress hormone. What that does is actually raise cortisol chronically. So when we're saying, oh, we're all stressed out, I need to do breath work, I need to do meditation, all these things, yeah, those things won't matter if the leptin isn't getting into your brain regardless. Then it doesn't matter. You're going to have cortisol being released essentially all the time, as long as it cannot get in there. Cortisol being a huge issue because cortisol actually releases sugar into your bloodstream. It's a glucocorticoid is what it's called. So as long as you actually have a stress response, that's actually releasing sugar. So that is kind of one of the ways we mentioned earlier. People completely cut out carbohydrate and sugar from their diet, yet they still have high A1C, high blood sugar, all these issues, and no one's really able to explain it. Then you end up taking Ozempic, but completely ignoring how this process works of energy accounting or metabolism. So and kind of from there, you end up getting cortisol coming from your adrenals. Then you end up kind of squeezing your adrenals dry, end up with adrenal fatigue, being very tired, not sleeping well, all sorts of issues like that. When you wake up, having a hard time waking up in the morning, all sorts of issues like that. Like I mentioned before, it has a bunch of different places all over the body that have leptin receptors. In the brain, it is probably the biggest part because that is going to be overall energy status, being able to get that leptin into your brain. But like I have here on this slide, there's showing all kinds of arrows all over the place to these different organs, because there's a ton of evidence out there showing basically how leptin determines the health of bone, the health of your heart, your cardiovascular system. It's what actually activates a bunch of your immune system. For thyroid hormone, it is 100% related to, your thyroid. When a lot of people actually have thyroid issues and come to see me, my first thought is leptin. A lot of times thyroid issues are misdiagnosed, in my experience, as actually leptin insensitivity issues. Things that are certain is that leptin sensitivity always leads to insulin resistance, and is going to always lead to thyroid issues, just by definition with how it works. That's why this picture is here of your pancreas, reproductive system. We already covered a bunch of these things about hormones, appetite, thyroid, all being related to leptin, because all these things use energy, and the only way to account for energy and use it properly and divvy it up is with leptin. Why reproductive issues are on here, that link comes again from leptin and cortisol. When you have high cortisol from not being able to receive leptin, what ends up happening is kind of a shunt to making all cortisol. What that looks like is we have a bunch of different sex hormones. Cortisol, you have your testosterone, estrogen, progesterone, all those kind of things. Kind of the pathways to making that is it starts with cholesterol, then makes pregnenolone. Pregnenolone makes all these different hormones. When you have very high demand for cholesterol, your body makes all cholesterol production go to cortisol and actually stops making things like testosterone, estrogen, pregnenolone, or not pregnenolone, progesterone, all those kind of things. And then you end up having very high cortisol, very little other sex hormones. And obviously that creates huge issues. And that's where our reproductive issues, a lot of those come from. Another tie into this, like I mentioned, cholesterol being there. When your body has a high demand for cortisol, what ends up happening is it needs a lot of cholesterol to make that. So your liver actually upregulates production of cholesterol, and right there, boom, you have your high cholesterol story right there. As long as you're having that issue with leptin going into your brain, you're having this entire web of all these issues that are going to end up happening. As you can see, it's going to affect your adrenals, your kidneys, reproductive organs, your liver, even at your muscles, it happens. So the idea being that how we actually store body fat, this is what food does and how it decides to store body fat, be released as heat or energy. What ends up happening is you eat food, and when you eat that food, about 60% of that energy from that actually goes to your liver. Your liver then stores it as kind of a fuel tank. It is kind of the auxiliary fuel tank that you have, and it stores a approximately 300 grams of carbohydrates. And that is used whenever your body kind of needs energy and doesn't have circulating blood sugar. So that's kind of between meals, when you're fasting, things like that, uses that storage energy tank that you have in your liver. And the other 40% of the energy you eat actually goes out to your muscles. And this is going to supply them with energy they need. They, to a degree, store energy as well, not as much as your liver. But when that food goes in either any muscle, what ends up happening then is it goes through that metabolism process that we covered earlier. It'll make the energy that it needs. It'll fill up the small stores that it has. Anything left over when metabolism is working correctly gets created as heat. If metabolism isn't working correctly, which is essentially that leptin hormone actually getting into the receptor in that muscle. When that muscle develops resistance and doesn't actually allow that accepting of leptin, what ends up happening is that you end up not being able to efficiently create heat and energy. Because it can't account for the energy within the muscle, then it basically what it says is, well, we're not going to store anything. We have no idea what the energy is. So it's not either an on-off thing either. It's kind of a gradient where you start off with slight leptin resistance and it ends up being kind of full blown. This muscle is completely leptin resistant at the end. So at the start, what ends up happening is, as you develop gradual mild leptin resistance, is some energy gets in the muscle, some heat is created. As it gets worse, you create less energy within the muscle, to eventually getting no energy within a muscle. That's where you get a lot of fibromyalgias and fatigues, things like that. Just general muscle soreness, achiness, all kinds of things along those lines. And some of it also gets created as heat. But as it gets worse, you create less heat, less energy. And pretty much you'll get to a point where just about 99% of it's stored as body fat. What ends up happening is it shuttles that energy back to your liver. When it goes to your muscles, it says, we can't use this. Leptin isn't telling us what the energy status is. Sends it to the liver. And what ends up happening is your liver also also having leptin receptors, that if the leptin can't get into your liver, what ends up happening is it also will not store any kind of energy within it that is not fat. What ends up happening is it stores all the energy you consume as fat, which is how you can have people then eat, barely anything. They could be fasting for 5 days a week, then eat 100 calories on the other 2 days, exercising like a mad person, and then at the end of the week, they gain 20 pounds. That is exactly how that happens. It's even despite not eating a lot of food, the food they do eat ends up just getting stored as body fat. But there's also other mechanisms within our body that actually create basically energy out of seemingly nothing. Our liver has a process called gluconeogenesis, and it actually creates sugar and carbohydrate out of non-carbohydrate products. And that's how you end up having just things like, again, more circulating blood sugar from seemingly, I'm not eating any carbohydrate or sugar, and I still have high blood sugar. Your liver can create sugar. Same thing, red blood cells floating throughout your blood vessels. They actually have a pathway called the Embden-Meyerhof pathway that actually creates glucose and sugar within them to do all kinds of things, which is why A1C can stay high, or does stay high. Not to mention there's another peptide called POMC, pro-opiomelanocortin, in our body. When certain conditions are met, it actually is kind of what determines different hormones get released. So it has a really strong action on actually releasing cortisol and insulin, like we talked about earlier. This POMC also actually has receptors for leptin as well. So if leptin can't communicate with that, you have dysregulated cortisol and insulin kind of going on. And lastly, our pancreas also has a bunch of insulin or leptin receptors. When you have high circulating leptin that can't get into receptors, what ends up happening is it actually damages the beta cells in your pancreas. Those are the cells that actually create insulin and will create insulin over time. So that's why whenever you have leptin resistance, if you catch it as soon as it starts, generally, you're going in a window of 3 to 8 years later, you're going to have insulin resistance as well. So leptin resistance always predates diabetes. Same thing with obesity in there as well. And just like we went through the cascade of thyroid and heart, blood vessels, bone, all those things will also start to kind of fail along with it because there's no energy accounting possible. All energy, instead of being used for useful things is now just being stored as body fat. And then as your body, even if you don't eat, your body then upregulates all the stress responses. Cortisol is releasing sugar, your liver's making sugar, your blood's making sugar. All these things, all that sugar, instead of actually making it and using it, ends up just being stored as body fat, which is why you can eat nothing and still store body fat. So that kind of all, we have some questions here. Let me look at this. Oh, yes. So someone asked, how do you determine if you're leptin resistant? Is there a test? So the really easy test that I generally have everybody do is if you look in a mirror. If you are 30 pounds overweight, you are, I'd bet you anything. I'd bet you my car that you're leptin resistant. Under that, you probably have a degree of it. If you look and you're like, I could lose a few pounds kind of thing. There might be a more mild degree to it. So I just call it the mirror test. That's one good way to find out. The second thing is it's actually not only in obesity as well, or weight gain or things like that. It's actually also the opposite end as well. So people with anorexia, people that are very lean or thin, to the point of where you're actually being sickly. And actually, to a degree, a lot of the really big fitness community people that really into fitness actually have a degree of leptin resistance as well, to where they may look good on the outside kind of thing, but actually on the inside, their biology is starting to fail. And they're actually going to have to pay the piper, so to speak, and kind of some years down the road. So actually creating leptin resistance by kind of manipulating their metabolism in a way that is not coherent with human biology. So the mirror test is the easiest way to do it. One way to do it with labs, which I don't really do, but you can, or if you have them on hand, is if you look at thyroid tests and you look at reverse T3 levels. Anybody with elevated reverse T3 levels will have leptin resistance. Our kind of how the process works to actually create our thyroid hormones happens in our liver, converting T4 to T3, our thyroid hormones. And when we are leptin resistant, the leptin actually can't get in there to convert that. What ends up happening then is instead of creating T3, it creates what's called reverse T3, which is kind of like a rogue T3 molecule that pretends to act like a thyroid hormone, but actually doesn't work like one. And then you end up having thyroid issues because of it. Your thyroid's kind of like the gas pedal of your metabolism. And that's what kind of helps your body actually create more body heat and actually kind of rev up energy production within it to kind of make that metabolism we talked about earlier actually happen faster. So you can energy on a dime, you can create a lot more energy or heat. So when we have conditions like hypothyroid type stuff, again, we can look at leptin as the main culprit for doing that. But those are kind of two ways you can use to determine leptin resistance. Another way is if you're not sleeping well, you also kind of by definition have leptin issue. And it's kind of why that is again, leptin surges at night. So really the really cool process, what actually happens is at night when we have 2 to 4 hours of darkness, that little clock in our brain actually signals the release of leptin from those fat stores. And how it does that actually is related to light signaling. So during the day, our cells generally actually create electrical charge. We talked about earlier with metabolism, it creates energy, electrical charge, and heat and water. As we shift into darkness during the night, what ends up happening is our cells stop creating electrical charge. Instead of releasing this energy as electrical charge, it actually starts glowing purple. This is extremely low frequency UV light. That is light that is in the UVC range. And for those of you who don't know how crazy that is, the sun that actually reaches the earth doesn't contain UVC. So our body actually has light receptors in it that are required to have light stronger than the sun, which is absolutely wild to think about that. That's crazy. So leptin actually needs 220 nanometer light, that's UVC light, to activate it. So if you're not having metabolism to actually create energy, such as your leptin resistant, you don't get that purple glow from your cells at night to actually release leptin into your body and actually go into your brain to do stuff. So I think that, we have another question here. So what might be the underlying causes or factors contributing to the development of lipomas? in the body. So lipomas are fatty lumps under the skin. The idea is there could actually be a bunch of different reasons for why that can happen, which is kind of not in this webinar. I will save that question at the end if we have time for it. I'll answer some of the possibilities that it could be. Just recently, I had a client that didn't have a gallbladder, and just knowing that gallbladder is responsible for digesting fat. And when we if fat moves through our metabolism, can't digest it, it's going to kind of get deposited in places that it shouldn't be. And she has a bunch of lipomas actually all over. So it's kind of working through that then would be trying to, it's not trying to, but kind of giving her advice in order to kind of have her replace her missing gallbladder. Gallbladders aren't really, the protocol for what you do after getting your gallbladder removed isn't really covered by surgeons after you get it removed. And there is things that need to happen to make sure you don't store fat and other stuff in places that it should be, essentially, and what to do when you don't have that gallbladder. So again, I'll answer it more in detail if we have time at the end. But good question. I like that one. So now we kind of went over all the metabolism stuff, how we store fat, the implications not only for why it is we're gaining weight and storing body fat. We went over also just the health implications as well. Of course, it's the weight loss is the primary thing we're talking about, but there's a lot more to kind of keep in mind that this is your health we're talking about too, which is really important. And that's kind of also, one of the main things we want to focus on. So now what the thing everyone wants to know is, what do we do about it? How do we become resensitized to leptin so we can kind of acknowledge our energy stores? Once your body knows how much energy it has, it can actually access its fat burning pathways. Otherwise, like I said, it just wants to deposit into your bank account and never withdraw. So in order to actually be a fat burner, you need to actually be sensitive to leptin. If you're not, you can try doing all of the keto dieting you want. It will never work because your body won't let you burn fat because it wants to hold on to that balance. It doesn't know how much it has. So this is, slides, there we go. 5 simple things to do. We want to resensitize to leptin. First of all, eating the diet that's right for you. This one has so much stuff going on with it, and it's actually be really simple when you understand kind of exactly what you want to do with diet. So let me go to the next slide here real quick. So diet is not only do we want to pay attention to what we're eating, we also want to pay attention to when. When is just as important. When it comes to leptin, the most important thing to remember is that it controls everything because it understands what time it is. So when you eat, it actually sends a strong signal to the clock in your brain saying what time it is, which is why breakfast is called breakfast, breaking your fast. It sends a very strong signal that you're awake, which is why it's very important to eat breakfast and why it's called the most important meal of the day. So this is kind of the general prescription I use for getting kind of using diet in order to resensitize to leptin. Now, this isn't a diet that's to be used all the time. It's just to be used to, again, resensitize to leptin. After you're sensitive again, then you're able to actually use different types of metabolism. When you are leptin insensitive, you are essentially a carbohydrate fanatic. It's what your body wants. It's the only thing it can use. It requires fast energy pathways. What that looks like is kind of like the difference between a kind of like a gazelle and a lion. Is a gazelle runs off of all carbohydrate pathways. It has a very different lifestyle than a lion. The gazelle is feeding all the time. It grazes all the time, which is why if your brain is hungry for carbohydrate, it's running off of only that metabolism. It creates this idea that you should also be grazing all the time. So snacking, that's where snacking comes from. Cravings come from. Sugar cravings come from. All those kind of things is essentially your body saying, we're a gazelle. I want carbohydrates. And that's why it's going to, say those potato chips look really good right now. Let's eat the whole bag. That's a good idea. As far as your body goes, it's if you gave it something else, it actually wouldn't even be able to use it. The metabolism doesn't work to be able to use other nutrition. So when it's your gazelle. Not only do you kind of graze all the time and snack, but you also will have a lot of trouble sleeping. Gazelles sleep less than 6 hours. Why is that? Is because how carbohydrate metabolism works is it needs constant input of energy, because carbohydrates are so limited in the amount of energy that they contain. They're a low energy food that doesn't have much for us. It's burned very fast. So you need to kind of keep re-upping it. Which is why then at night when you're, waking up early, things like that, it's actually your body saying, I'm hungry, I need carbohydrates, I don't have any energy. Doing that, obviously, it kind of shows up as different symptoms, not only just having trouble and waking up throughout the night, but also things like sleep apnea, or things that will happen where your body will do all kinds of different symptoms actually to wake you up. Because first of all, it doesn't need to sleep as long. Longer sleep is more lion lifestyle. So lions generally eat a lot of fat, a lot of protein, and they sleep a whole lot. They use pathways that are related to fat metabolism, essentially. When they eat like one big meal kind of thing, and then they sleep like 20 hours a day. And those allow them to actually store massive amounts of energy. So within us, we have both pathways that we can use. And depending on, again, context, where we live on Earth, the season we're in, all these kind of things contribute into kind of what diet you should be eating. So we're probably somewhere in between a lion and a gazelle to where we can use both, but depending on where you're at, one is going to be better than the other and going to be healthier. So again, going back to kind of the overall prescription here, being that we want to kind of realign the time in our brain to get us sensitive to leptin, how we can use food, eating 30 minutes within waking up. This is sending a super strong signal to your brain. It is daytime. The transition from night to day has started. Same thing with eating lots of protein for breakfast. Same idea. Protein sends a very strong signal to your brain that it is, again, it's having to pick up metabolism due instead of carbohydrate consumption in the morning. It's very simple, straightforward, very quick, versus it takes a little bit more to digest proteins and fats. Not only that, but eating that much protein, if you have a leptin issue, what ends up happening is the proteins within your body actually degrade, and you don't have the ability to replace them very well. So by eating lots of protein, you're able to kind of use that. Having more available allows you to replace proteins a little bit better. Number 3, limit carbohydrate intake. I feel like it's a little self-explanatory, just based off everything we kind of said. When you're taking in carbohydrates, it's going kind of completely against kind of the sensitivity that we're trying to get from leptin. That's the pathway your body wants to use, just because it's in starvation mode. Again, like I said earlier, don't count calories. Not useful. They're not important for anybody who's leptin sensitive. You actually don't even really create a lot of body heat because, again, metabolism is trashed. So calories aren't even, if this package says 100 calories, you're probably getting like 5. So it's actually completely the opposite of the way people generally think about calories. Number 5, no snacking, fasting, or drinking coffee. Again, all things that send signals about time to our brain. Snacking, feeding, like I said, that's gazelle stuff that generally tells you what time it is throughout the day. It's kind of lacking that idea of time. If you're eating all the time, especially after the sun goes down, eating should be happening when light hours are present. Which is why I said allow 4 hours before finishing supper and bedtime. Ideally, too, that should also be when the sun is still up. Our physiology completely changes at night and flips to a very different program. And if you eat food, it signals awakeness. And that's obviously not what we want to do. That is desensitizing us to leptin. Fasting, same thing. If your metabolism is trashed, fasting won't work for you anyway. So you're just punishing yourself at that point. So no intermittent fasting, long-term fasting, none of it. Not a good signal to be sending to your brain. Drinking coffee, same thing. We already have a cortisol issue. We don't want to stress our adrenals even more and drive dysfunction any deeper. Eat lunch only if you're hungry. The idea is that you want to eat a huge breakfast and you want to be full at breakfast. And the idea is at first, you're going to actually be hungry before you get to supper time. As you become more leptin sensitive, what ends up happening is you won't be hungry. The appetite will go away. And the idea is we want breakfast to get you to supper time. That is the idea for resetting time. And then at supper, again, we want you to eat a pretty good amount, not necessarily as big as breakfast, but just eat to your kind of full, prioritizing fat and protein and limit carbohydrate to reset time. Eating that supper also helps kind of surge insulin just before your kind of the darkness hours come in, which kind of also sets the stage for leptin. So another way it kind of setting that time within your brain. Eat locally and seasonally. Our diet is basically if I can give one thing about diet, what you need to do is eat locally and seasonally. That determines what kind of diet you should be eating. Somebody at the equator eats a very different diet than my brother in Antarctica. Like I said, fruits and vegetables for him are a toxic food. They're not even close to being a health food. They will kill him faster than he wants to die. When you're at the equator, you have very intense light where those foods actually grow. And you have the light signals to actually program your microbiome to be able to digest and use those foods. So to be able to use any kind of food, what needs to happen is the light in your environment needs to match the microbiome that's present in that environment. And it needs to match the food. When all those things vibe, then that's when it actually be a health food for you, which is why carbohydrates further from the equator aren't a good idea. Your body doesn't have the microbiome that's present in the soil that you grow all the food, and it doesn't have the light signals that you actually need for your metabolism to digest those foods. The idea being that our metabolism in our mitochondria within our cells, they require different types of light to actually digest food. When you don't have strong light, it makes that metabolism very inefficient, which is where we talked about the uncoupled and coupled metabolism earlier, is when you have weak light signals, you end up having uncoupled, very weak metabolism. You tend to favor creating heat over energy, and you need to eat more food. It also doesn't have strong enough light to actually break the bonds within food that were created by very intense sunlight, which is why in cold environments where I'm at, we're going to be getting into winter in the next month or two. That is when there should be no carbohydrate consumption because carbs don't grow in winter. And so that's why they're always not going to equate. And essentially they're always going to cause issues, and essentially inflammation is the way to understand it. Regardless of whether it's, on Instagram, people post pictures of these healthy fruit and vegetable bowls with healthy grains, things like that. And meanwhile, they're located in Michigan and it's in winter. That is just going to basically create a bunch of blood sugar, leptin, insulin, and inflammatory issues because the signals don't all equate to one another. You won't be able to use that. So eating locally and seasonally holds true for not only this, but also just kind of how you should always eat in general. And why there's no magic food everybody should be eating to lose weight. That doesn't make sense. The last bit is prioritizing eating seafood over other types of food. So not only do you want to eat locally and seasonally, focus on fat and protein, we want to be eating seafood, and red meats are kind of the main things. Eggs too are also kind of the things we want to prioritize eating over other foods. Seafood specifically because it is nature's basically multivitamin. It contains everything we possibly need and is actually the reason why we have the most complex brains on the planet and why we do what we do, why we have these massive frontal lobes that allow us to do complex thinking. When you have leptin issue, you have brain degeneration. It cannot account for that energy status, and your brain is the most power-hungry organ in your body. So by using seafood contains DHA, which is a huge part of how we make our brain, has a huge electrical charge, and really allows us to reset time within our brain much faster. Which is why we said that. So that is kind of the basic ideas behind that. I know that a lot of times people have a lot of questions that come off of that. So we'll get to that in a little bit. Real quick, we'll cover the last few here. So proper sleep hygiene. We have a quick question real quick. Let's see here. I don't like seafood. Is taking a multivitamin not the same? Taking a multivitamin is not the same. So not all nutrition is equal. One example I'll give you is that in many people supplement fish oil pills for the omega-3s in them. Again, the fish oil, the omega-3 in the pills is not the same as if you caught a salmon in Alaska, and the omega-3 from there are not the same. The difference being that on the surface to us, they look exactly the same, but we actually start looking deeper into what happens when they actually process supplements, like when they squeeze the oil out of the fish and put it into the pill, and you start looking at it like under microscopes and things like that, the molecular structures of both aren't the same. The thing about the human body is it's very specific, atomically, molecularly, all these things, to where when you have slight differences, they are not the same. So what happens with omega-3s is there's a little arm on the molecule that needs to be in a certain position. During the processing process, putting it within the pill and the capsule and doing all those things, what ends up happening is it actually changes the position that arm is in, meaning that it actually can't cross the blood-brain barrier to actually get into your brain. So that fish oil pill, sure, a high quality, a good one, it should be refrigerated. There's a bunch of ways you want to also check to make sure you're getting good product. But that doesn't get into the brain. It gets everywhere else, sure. But we really need it to be in our brain is a huge thing, which is why fish oil pills will never help any omega-3 related brain condition. They can't get in there. Not even the pills, but even just kind of like the squirt bottle stuff too. None of that will actually be able to get in there. It doesn't matter if it's from krill or fish, whatever source of omega-3, they're not going to be equal. Same thing. There was a webinar last month that I did that was talking about vitamin D. And again, we went over that, where there's very specific controls within your body and environment where things are not the same. So vitamin D, taken in a pill, goes through your gut. Vitamin D, if you look through all of our biochemistry, is created in the skin. We don't have ways to absorb vitamin D efficiently in the gut, which is why you can take all the vitamin D supplements you want at massive doses, and you'll never get to vitamin D levels that you need to get to. So no, any supplement is never the same as the real thing, which is why I get everybody off of all supplements. They actually will cause more damage. So vitamin D example being that when you have vitamin D in your gut, it'll actually tell your body to downregulate what's made in the skin. Meaning that not only are you not getting vitamin D, but you're actually destroying your ability to make vitamin D. So that's why we want to get real stuff all the time. There's a lot of good reasons, and just about all supplements are going to be detrimental in some way. Someone else asked a good question too. Low leptin may contribute to dementia? ? Yes, absolutely. The idea being that dementia, Alzheimer's, Parkinson's, all brain related degenerative disease is based off of how much energy is within our brain. We can see this if you look in all those degenerative brain issues, there's a pocket in your brain called the substantia nigra. It's full of melanin in there. In all brain degeneration, what you see is the melanin leaves there. So melanin being the same thing that gives your skin pigment. So what that substantia nigra looks like is a dark black patch in your brain. And actually it's super electrically charged, which is what actually gives your brain a lot of energy. Your brain's actually also made of all fat almost. So there's a ton of energy within your brain, but if your leptin can't get in there to actually regulate that energy metabolism, what ends up happening is what we see in all MRIs and brain scans too, is that the substantia nigra loses that melanin and it loses that energetic electrical charge, basically because it can't account for the energy within there and the connections in there. Not only that, but those are all in degenerative brain disorders. There's always kind of damage to that hypothalamus where that brain clock is in there. That actually connects your eyes to your light environment, to your brain, to the leptin receptors, where they're all actually feeding into one another. And a big part of why leptin surges at night is actually involved in regenerating your brain and helping it heal from brain degeneration and reversing those kind of things. So as you become more leptin sensitive, you actually will be healing your brain if you do all these things I'm giving you right here the right way. That is a fantastic question. And I hope everyone picked up on that and how important this is. And I can also talk about that. That should probably have its own webinar, which we can do in the future for sure. But just for sake of time, I'll finish up with these last few points and then we can cover a few more questions. Number 3, stop exercising. This one usually boggles people's minds because, the idea is what everyone tells you is eat less, exercise more. I'm telling you to eat more and exercise less. When you are trying to get leptin sensitive, exercise, you can't use it because exercise creates hormonal responses. It uses energy in a certain way. And when your metabolism is trashed, you don't have, like I said before, energy can't get into your muscles. They can't get it here or there. Our hormones are also going to be trashed because, again, our cortisol it's all our bodies wants us to do is make cortisol, and it can't use any other sex hormones. So it can't make vitamin D, it can't make testosterone, it can't make estrogen, all these kind of things. So exercise doesn't benefit you at all. So at most, I just want people walking relatively slowly, nothing crazy, not power walking, just walking, not even a whole lot. Generally, the more you exercise while you're leptin resistant, the faster you'll actually and more weight you'll put on. So that's just about that. Just don't exercise until you're leptin resist or leptin sensitive again. When you are, that's when you can actually reintroduce exercise, and it'll actually be useful for you to actually be able to leverage change from that exercise instead of just using it to burn calories. That is a super inefficient way to burn calories. It's so small what it does that it's just negligible. It should be instead kind of used for just moving, optimizing our kind of mobility and things like that, but not be used for directly burning fat. Kind of an example, a quick one, even though we're not there yet. The fifth one is cold exposure. If you compare the amount of calories burnt during exercises versus just something like a cold dunk for 45 minutes, is a cold dunk for 45 minutes is basically the equivalent of running a full marathon worth of calories. So would you rather sit in the cold dunk for 45 minutes or run 26.2 miles? Exercise is super inefficient actually at using energy. So not a good way to do it. And why at first, when you're not sensitive to leptin, stop exercising, not useful. But definitely go on nice strolls, walk the dog, go outside, touch grass, those kind of things. Just move around lightly, nothing crazy. Number 4, it's bolded because it's the most important one. This is 100%. If you don't do this, none of the other stuff matters. This should be your number 1 priority for every health concern that you have. On my list of the top 10 most important things for health, it is number 1, 2, and 3. Diet and exercise are 8 and 9. Everything behind light on the list doesn't work if light isn't in place. That's why I said you can eat the diet that I just told you. You can do everything else, but if you're not paying attention to your light viewing behavior, you're going to be suffering. And kind of how that looks like, what that looks like is our brain, our clock in our brain is always looking for signals to set all of its rhythms. If you look at all the hormones, all metabolism, they're always going up and down in waves. And this is all correlated to basically light cycles is the primary way that it does that. When the sun rises in the morning, our sunsets are nice and red and orange and yellow and pretty. And as they go up in the sky, you get more greens, blues. And as it sinks again, you change colors. The idea is all those changing colors have different information that encodes different hormones and processes, things that happen in our body. That's why cortisol spikes in the morning. That's why when we have darkness at night, melatonin is released, leptin is released. All these different things, they're all controlled by light. And that's why the part in your brain that controls all your hormones, all your metabolism contains the clock in your brain, is connected directly to your eyes. Without that, nothing matters. So what we want to do here is we want to get as much natural sunlight as possible. So what that looks like is in the morning, I want you to get at least 30 minutes of morning sunlight. That is sunlight from sunrise. You can check on the phone or weather app or whatever to see when sunrise is, and about 2.5 to 2 hours after that is the window that you need to be getting a half hour of that. That is what sets the tone for your body understanding that it is morning. If it doesn't understand that it's morning, it has no idea what time it is, all your metabolism hormones are going to be dysregulated, and you will have a lot of inflammatory conditions and degeneration and all kinds of different systems. So that's kind of part 1. Then the second part being that we want to also get our light throughout the day. The idea is as the light changes, it's encoding for different things within our body. So midday sunlight will actually tell your body to do something. Then morning sunlight, sunset sunlight will also tell you something different. So I say you want at least 3 square meals of sunlight throughout the day to give your brain and your body the different signals that it needs to actually create all the hormonal and metabolic responses that it needs to do. So viewing all these times and even throughout the day, finding ways to actually connect to light. One thing not a lot of people know is windows filter out light. If you tested with a spectrometer, the light on the outside of the window, it is full spectrum sunlight. If you test it on the inside, it cuts out a lot of that light, specifically the purple and red light from it. And relatively, it actually makes an imbalance within the light, actually creating a stress response within us. The POMC molecule that I mentioned earlier, when it is hit by specifically blue light wavelengths, it actually releases cortisol into your body, which actually, again, releases sugar into your blood. So that's why in the morning, we get that blue light hitting our eye. We have a cortisol spike naturally. That's what it should be. The problem is when we live indoors under artificial light, what ends up happening is if you test it again, the light that comes from artificial lights, I don't have any in here, but that light is predominantly blue. So what ends up happening is as your eyes and your skin and all your light receptors within your body are picking up that light signal, how it reads blue is release cortisol, blood sugar, and insulin into your body. So as long as you're sitting at work in artificial light in front of a computer screen that is unfiltered, has all the blue light coming through it, you are constantly having sugar released into your bloodstream. Not only that, but artificial devices always release blue light that's more intense than the sun ever provides, meaning that it's also, again, just a chaotic signal that's unrecognized and will damage the clock in your brain and lead to a wide variety of degenerative and inflammatory conditions, including weight gain, obesity, all that kind of stuff is an inflammatory condition, not only body-wide, but predominantly in your brain. Again, leptin, the primary target is in that brain receptor that it needs to get into. So the idea with light is, in a nutshell, is you want to see as much sunlight or natural light throughout the day. A trick you can do is actually just crack your window. Over here I have a window cracked just like, half inch, quarter inch, not much. The properties of light allow it to bounce and bend and flow and do all kinds of stuff, so it doesn't take much. So anytime I'm indoors, I have a window cracked around me. If I'm driving somewhere, I always have a window cracked, even if it's one in the back, it doesn't matter. That's the way my eyes are actually always getting connected to the right light signals that are actually programming the clock in my brain. So that way I become very leptin sensitive to that way when it comes to nighttime. The flip side is we want to kind of eliminate all the artificial light we can. That artificial light, your TV, your phone, your computer, the lamp next to your couch, all those things emitting artificial light, what they do is send a signal that is daytime. And as soon as you, like I said, leptin surges at night. If your body thinks it's daytime, you're never going to have that surge, and you're never actually going to be able to account for your energy and regenerate. And like I mentioned, there's a question about dementia. Regenerating your brain happens at night. So if you're having light exposure at night, you're actively degenerating your brain, driving conditions like obesity and weight gain, and other inflammatory conditions. Just like when our body stores fat, that's how you end up with like fatty liver disease, is when the leptin receptors don't work. It starts storing fat all over the place, and that includes on your liver. And how it determines where to store it is kind of based off of sex hormones, which is why men and women store fat differently. But kind of to sum up light, again, is at night we want to eliminate all sources of artificial light. If you're doing that, you're having, again, constant exposure to blood sugar. Most people throughout the day always have some kind of light on. People sleep with the TV on. People have night lights. People, you wake up, immediately turn on the light in the bathroom. All day you're at work. You're getting 24/7 release of cortisol and blood sugar. And there's no way your body can actually burn that fat because it's in a panic mode in carbohydrate metabolism. It can't access fat metabolism, and you just kind of keep adding it on despite the diet and exercise that you use. So again, emphasize, light is the most important thing. Without it, nothing matters. You can't use food. You can't use exercise, anything like that. So we have another question. DHEA/seafood increases leptin. Is it the same response? Seafood increases leptin. I'm not sure I completely understand the question, but I'll do my best to kind of answer it. It's not necessarily seafood increases leptin. It essentially increases the see how to put it. Increases the kind of the charge available for your metabolism and kind of helping the sensitivity of the receptors within your brain. It's part of rebuilding the ability for your brain to accept it. Different things in seafood, like DHA being the primary one. Our brain is made of a ton of DHA. DHA is a huge part of our eyes too. It's in there because DHA has the ability to capture a lot of sunlight, is what it does, which is why animals further away from the equator always have a lot of DHA, and then like fish closer to the equator don't. You can't find DHA really at the equator at all, because it's what allows them to actually replace the lack of sunlight in their environment, because it has such a strong ability to actually kind of create light within itself. Really, when we get to it, it's kind of a weird answer, but seafood is actually the DHA in seafood is a package of really dense light. But not all seafoods are created equal, to where the seafood I'm talking about is fattier seafood. If that is the question, DHA in seafood is only in the fattier stuff. The leaner stuff has it, but in smaller amounts. So you do want to focus on fattier seafood, DHA, omega-3 rich stuff. So like something like salmon is really good for that. Something like tilapia, not so much because it's very lean, not very fatty. Therefore, it doesn't have a lot of DHA. Therefore, it doesn't have a lot of energy for your brain to use specifically. Fatty fish is the best brain food you can get. So I think that might be been more the kind of the answer to that. Is we don't want to take a supplement again, though. We want to get that. The seafood idea is it's targeted for the brain. Taking that omega-3 supplement, fish oil supplement, doesn't get in the brain the same way, just again because that little arm on the molecule can't pass the blood-brain barrier. So we want to eat nature's intended full package for food. There's a reason why all the nutrition in food is in there. One example of that being when you take iodine by itself, what ends up happening is you can actually develop an immune response to iodine, because in nature, iodine doesn't occur by itself. Anytime you find iodine is something where it's in seafood. Seafood's the best source of iodine. Again, another reason why I want people eating seafood. But that iodine, when it is in seafood, what happens, it has all kinds of other things. Like when you combine selenium with iodine, it makes it so your body won't have an immune response to that iodine. That's why you're causing harm when you start going in the avenue of isolating substances and starting to take all these supplements. Is you don't know the implications, because our body's so specific in how it uses nutrition, energy, and relates to the environment, that very small changes can have huge impacts. Which is why I'm talking about artificial light. We don't feel damage from it necessarily. Sure, it can cause headaches, and people are like, oh yeah, when I'm on the screen all day, I feel a headache. But as far as it raising blood sugar and kind of putting on weight, you don't really feel it because it's so subtle that it's happening. And it's kind of like, you 10 years down the road, you're saying, oh wow, it's like I started here and now I'm here. You don't realize things in very small amounts because our brain isn't that detail oriented. Kind of how it works is we kind of lose that ability to kind of decipher those things, which is why I want to be very specific with the stuff we put in our bodies and our light viewing behavior. So something just like light at night, our body's super sensitive to light at night. As little as 5 photons it can pick up on. That's the equivalent of the little blinking light in the smoke alarm. So if there's no other light sources, you have completely blacked out room, and you just had that little blinking light, your body actually recognizes that that's there. It actually will, to a degree, cause leptin desensitivity, as well as destroying your melatonin. So that's being super picky. You can probably live a long and happy and healthy life, even if you have the blinking smoke alarm in your room. But it's just understanding how these things work and how specific our body is when it comes to these things. Which is why at night it's even more important to pay attention to your light viewing behavior than during the day, because we're so much more sensitive to it. We only get melatonin and leptin, the 2 master hormones, when we have complete darkness for 2 to 4 hours at night. So if you're watching TV before bed and you go to sleep, you got to wait 2 to 4 hours before you even get it. And the thing is, we actually have, if you don't get that surge between 12 and 3 a.m., you actually won't get it. So which is why it's kind of important when I kind of glazed over the sleep hygiene bit here. But the sleep hygiene, the idea is we want to be in bed by 10 at the latest. When we go past that, we're going to miss out on the surge of melatonin and leptin and all these things that we need for our health. So when it comes to sleep hygiene, we want to have a completely pitch black room we're sleeping in. It should be very cold. Cold enhances our ability to actually use leptin and accept it. So when it comes to sleep, you want to eliminate light again. It should be cold. The last bit is about cold exposure. Cold is absolutely amazing for what it does. Not always necessary for what we're doing here, but is definitely something I always recommend just because of the insane effect that it has and the ability it has to actually burn fat. So one thing it does, not the primary reason, but one thing it does is actually changes the type of fat you have from white fat into brown fat. White fat gets deposited in certain areas, and that's what's inflammatory and hurts us in really bad ways, and that's the stuff that we don't want. Brown fat is located everywhere under our skin and is what is responsible for actually creating a lot of heat. So earlier when we were talking about uncoupled metabolism creating a lot of heat, a lot of that comes from when you start actually cold adapting your body, you end up with more of those uncoupling proteins in your brown fat, and that allows you to burn a lot of heat. Not only that, but when you are exposed to cold, what ends up happening in the clock in your brain, it actually overrides using light signals primarily, and it starts actually using, your brain actually starts controlling itself in a way. So cold has a really strong response, and this was because as we moved away from the equator, we didn't have light controls, because as we move higher latitudes, we end up having not a lot of light. We have long dark periods and a lot of cold. So we can't rely on light up there, which is why as you get further from the equator, you need to rely on cold instead. And when you have cold being the primary driver, is you change your metabolism in a very useful way that it creates a lot of heat to keep you warm. Even if you're outside, you could be naked in like 30-degree weather and actually feel very warm when you do this cold adaptation and exposure correctly. So it's creating that environment to create a lot of heat and actually allows you to access fat burning pathways. So as you move, again, further away from the equator, there's not a lot of carbohydrate present. So as you actually make your brain adapted to cold, it actually doesn't handle carbohydrate well at all. And that's when you should be using kind of carb and fat, or not carb and fat, fat and protein in order to, that's what's available up there. It would be animals, animal fats, animal proteins that would be available there. To actually, that's because you're using fat burning pathways when you're cold adapted versus just about mostly everybody watching this is probably warm adapted because you're never exposed to cold temperatures enough to actually be cold adapted and access those pathways. So when you're warm adapted, you end up being definitely a carbohydrate dominant person, and you're not good at using fat burning pathways. You can think about that as warm adapted people being people who are near the equator, cold adapted being away from the equator. Near the equator, there's a lot of carbohydrate present, lean meats, things like that, not a lot of fat, and a whole lot of sunlight. And that's kind of how you should be living. So it becomes very dangerous when you move into winter, like a place where I'm living in January when it's really cold outside, but you're a warm adapted human who doesn't use fat well and uses carbohydrate. Even though carbohydrates don't grow in that season, that's a huge mismatch, which then creates a ton of mismatches within your brain and in your chemistry and in your biology that creates a bunch of inflammatory conditions causing degeneration. So the idea is we want to pay attention to those mismatches. Cold is a fantastic way to always override whatever system you're using. Cold has a lot of ways to actually save our lives in really big ways. I had a client who did not have a thyroid, had all these thyroid issues. When you cold expose and become cold adapted, you can actually get away with not having a thyroid and have completely normal thyroid levels, which completely blew away their thyroid doctor's mind when they didn't have a thyroid yet everything was functioning as it should, because cold is massive. How thyroid hormone usually works is it requires a lot of intense sunlight. The process of making it starts in our eye. So having this fail-safe within our body where we don't need that light when cold is present allows us to get away with actually not having a thyroid, leveraging this, basically our mutation to one of our genes to actually our benefit to helping people without thyroids or thyroid damage. So doing cold exposure not only helps the leptin issue, but again, it helps the cascade of everything else we're dealing with. It is also the just absolute best way I've seen to just absolutely melt body fat. This is actually already being used today, which not a lot of people realize. It's called cool or cold sculpting, where they take metal and make it really cold, and then they'll put it on people's bodies in certain areas. And what it does is actually makes the fat basically go away. It creates cell suicide within fat cells. This was discovered when scientists were looking at people with frostbite. They always realized under the frostbite, the fat would always be gone. So that's when they started saying, how can we sell this? Let's make metal really cold and start melting people's fat. And people do that. The only problem is it's going to come back because it doesn't address the leptin issue, and they're not fully cold adapted all over. You're just using it in specific areas, and it's going to create a temporary response. But then your liver and everything's going to go back to just packaging fat in those areas. So there's a whole lot to that story that it gets really cool. But just for the sake of time here, I think we're going to wrap it up. Let's see. Got some comments here. This is great. So if you have any questions now, throw them out there and I will answer them to the best of my ability. I hope everything makes sense. If something doesn't, please ask the question and we'll clear it up because you're probably not the only one that might have missed something. I know this is a very different way of thinking about things. But so I hope it kind of opened your mind up to different possibilities as to how our body really works, what it needs, and kind of what to do about things. Like I said, all the answers here I gave you don't create customers. This puts the power in your hands to be able to access your health and make the decisions that you need to do it. So it's just when you know better, you do better. And you can ask better questions of doctors, medical professionals, me, anybody. And I encourage you, if anything felt very different or you're not sure about it, fact check me. Please do. And you'll realize that, there's some pretty cool things when you start actually doing the research. I'm just a big nerd that kind of put these things together, and I'm delivering it for you, to you. And I'd be happy to help you more with it as well along the way. I work through a web app called Meridiogram, is where I do a lot of my work, helping people along with these things. It is a health questionnaire that gives you a holistic assessment of what's going on with your health, and from there, depending on which kind of package you get, you can have more guidance or less guidance along the way, and have access to all kinds of extra goodies beyond just these webinars that I do. Because there's a lot to this story, and you kind of got the tip of the iceberg today, so I hope you enjoyed it. We will have a special for anybody that would like to sign up and spend some time with Meridiogram to tackle your health in a holistic, responsible, well-educated, thoughtful way. And I'll be happy I'll follow up with that with an email. If any questions come up as all this information is marinating, or you need any more help, please shoot me an email. I'm happy to help and answer any questions. You guys are awesome. Thank you for listening. I appreciate it. And I'll stick around for a few minutes in case anything pops up with any questions here. Oh, the lipoma. Yeah, that's right. The lipoma question. Yeah. Okay. Yeah. So lipomas. So I answered it kind of, we talked about kind of the gallbladder. And I've definitely seen that as a pattern in practice. The idea being that when you don't have a gallbladder, your body has to do something with the fat. The other thing that I also mentioned along the way, kind of about DHA and fish, things like that, is that fat has a lot of electrical charge. Just like I mentioned earlier, carbohydrate versus fat metabolism is carbohydrate is very electrically not dense. Versus fat is very dense in electricity, as well as the ability to create heat. So fat tends to go to places that are lacking in energetic charge. So what you see as something like, as you get leptin resistant, is your, and it can't get into the liver. What your liver starts doing, which you'll notice like in fatty liver disease, it'll start packing fat onto the liver, because any organ, tissue, whatever it is, what it has in common is any kind of degeneration always equals less electrical charge. Actually, I have a tool in my office that I use to test electrical charge of all different organs. If it's anything less than 100, then I know there's an issue with that thing. So fat goes to these places where it needs electrical charge because it actually offsets electrical charge and donates it to whatever it's kind of hanging out on. So if you have these lipomas in certain places under your skin, if it's like on your abdomen, it could be because it's over a certain organ. If it's like something on your forearm, I'd guess more so it's related to something that's happening there. It could be the skin doesn't have enough electrical charge. The thing is, when a big part of our skin physiology deals with how light hits it, it's based off of Einstein's photoelectric effect, where what it says basically is light comes down from any kind of source. When it hits matter or electrons, in our case, in our skin, it kind of creates more electricity within it. So when our skin doesn't receive the light signals that it needs to, it ends up dropping in electrical charge, and we'll have things like having lipomas or fatty deposits in those places. The idea being that we don't have enough electrical charge. Let's send this fat that's very dense electrical charge then to kind of donate electrical charge to the skin. Not a good way to do it, but our body's really smart at adapting, and that's why it does it. It's essentially saying, I know this isn't the best thing to do, but it's all I got for you as the solution. Does that make sense? And do you have any more questions about it? So if kind of like how to address it then is if you wanted to, if it's the example being wherever it's at, really, if it's lipoma is generally kind of going to be related to the skin, the charge in the skin. So what you want to do then is, I guess that you probably don't get a lot of sun exposure. Two different avenues you can go on, or you can use both. The idea is if you're living in a place that has a lot of sunlight available to you, you can use the sun. And if you put sun on that area, it will clear that lipoma. It'll actually, when it raises an electrical charge, it won't need that fat. And you actually have all kinds of things in your body, like lipases, that actually circulate through and actually eat away fat that shouldn't be where it is at. And secondarily, you can also, what I said earlier about cold, is cold melts fat. So if this lipoma is all over your body, I'd recommend fully immersing in cold water. If it's in a certain area, you can actually put like a cold pack, or just submerge your arm or wherever it's at in cold water. Generally using water about 50 to 55 degrees is where you want it to be at. And that will, again, eat away that fat and take care of that lipoma. I think that about covers it. You can definitely talk more about it, but I think that's kind of the basic idea that we'll get to the bottom of that. So I'm going to post a link to the top 10 most important things for health, so you can check that out. Let's see here. Great seminar, very different approach. Appreciate. Can you perhaps tell us your normal daily routine, as you probably have optimized everything? That is a question we probably don't have time for, unfortunately. But everything I'm saying here, if you kind of think about the basic tenets about everything I kind of told you, is you want to pay attention a lot to what your environment looks like. Take a look at what naturally occurs there. So I'll give the example of, for me right now, what it's looking like being in Raleigh, North Carolina in the United States. We are transitioning from summer into fall. We're getting drops in temperatures. We're losing the amount of light that we have. We're actually about to completely lose our UVB light, meaning I won't be able to make vitamin D when I'm out in the sun anymore. And that'll stick around until about March, April, that I won't be able to use the sun to make it. So that being said, I know I can't use light as efficiently, and I know temperatures are dropping. So I know that I need to switch over to being a cold adapted human. So I've been, for the last month now, really diving into lots of cold water immersion and having some really great benefits from it. It's in the mornings right now, we're getting to about 45 degrees. I can go outside no problem in just a pair of shorts. And I'm sure when it gets colder here in the next few weeks, I'm still going to keep up with it. It's really cool to see that happening. I'm not going to go over everything, but that's kind of the idea. Take a look at what's going on. If you have lots of intense light present, go out in it. If you don't, get cold. Take a look at what foods are available where you're at locally and during that time of year. So right now I'm stopping eating all my carbohydrate sources because they're going to stop growing now. So that's why, cookies at Christmas aren't the best idea. And I probably will eat some, I'll be honest, but it's not optimal for me. So good question. And if you shoot me an email, I'll be happy to talk to you more. And I'd be happy even maybe to do like a consult with you or anything. So shoot me a question or shoot me an email. All right, that looks like about it. So I think we're going to wrap it up. Thank you guys all again. You guys are awesome. You ask really good questions too. I love it when people ask good questions here. I see you asked for my email. I will type it in right now. There you go. Yeah, shoot email to that email right there, and I will be happy. We can talk more about it and get you on the pathway to optimal. So yeah, that about wraps it up. I think that's all the questions. If anything does come up as well, anything extra, shoot me an email. I'm happy to talk. I love to talk. So I'm going to close it now. So if anybody needs that email, go ahead and write it down. I'll stay here for a few more seconds so you can write it down. Hope you guys learned something new today. Like I said a couple times, I'm a big nerd. And I really like learning and sharing what I learned because it's so fascinating and so different. And it works so well. And it's crazy to see how our health really is in our hands and not in somebody else's, when you know how to use your environment and, just different aspects of how our body works. It starts being evident that our healthcare system is failing us and not very good at chronic modern disease because of a lot of these things that I found. So thank you guys for tuning in. I had a lot of fun. I hope you guys did too. And I hope to see you in future webinars and future talks and get to know you guys a little bit better.